we're gonna begin. First of all, I want to say thank you for everybody for showing up today on our Monday's workshop. Today we're going to talk about TinkerCAD and Breadboard 101. So TinkerCAD is a free online 3D modeling program that runs in a web browser known for its simplicity and ease of use. Since it became available in 2011, it has become a popular platform for creating models for 3D printing, as well as an entry-level introduction to constructive solid geometry shapes in schools. It's also written in WebGL, which is a JavaScript application programming interface for rendering interactive 2D and 3D graphics within any compatible web browser without the use of plugins. I know I've said a lot that TinkerCAD is very useful for 3D designing, but it's also good for simulating circuit board circuitry and also for coding. So since this workshop's going to be interactive, I want to make sure you guys can make an account on TinkerCAD. So if you can just simply go to www.tinkercad.com, and I'll also put it on the chat so you guys can follow along with me. Is everyone there?
Yeah.
Yeah? Okay, awesome. So how to make an account is fairly simple. On the top right hand, you're going to say where it says join now, and you're just going to simply click it. And then from there, there's two ways where you can sign up. Usually if you have, if you're doing this with a professor, your professor will give you an access code, but since, we're doing this for more of a personal use, that's where you can make a personal account using your email, or you can sign in with Google or with Apple. For me, I signed in with my UTRGV email address, so you guys can do the same if you like. And then once you go from there, you're just going to simply create your account. And once your account is created, this is how your homepage is going to look like. And I'll just give, probably 5 minutes for you guys to make your account. Or you guys can let me know. Has anyone ever used TinkerCAD before?
I believe I have. Yeah.
Awesome. Yeah, especially since everything's online. I know Dr. Lee, he likes using TinkerCAD for digitals. So if you guys have him, you might be using TinkerCAD. Or if you have Dr. Kumar too, he likes using TinkerCAD as well. Oh, hi Randolph. How are you? I didn't see you. Who else is here? Trey. Hi, Trey.
Hey, what's up, man?
Welcome, welcome.
I'm eating, so that's...
Oh, yummy. No, it's okay. Don't you worry. It is dinner time. Early dinner. Or late lunch, if you haven't had lunch. Has everyone are they at the homepage yet?
Yes.
Yeah, everybody is?
Yeah, I am too.
Okay, awesome. So this is going to be an example of today's TinkerCAD. We're going to be using a small breadboard, a resistor, an LED, a push button, a power supply, and of course, some wires. So before we go into simulating for today's workshop, I just want to give you a little breakdown on how a breadboard works. So like here, this is a small breadboard. It's half the size of a breadboard, which consists of 30 rows, 10 columns, and 2 pairs of power rails. The breadboard is a powerful prototyping tool that will let you take your electronic skills, obviously, to the next level, and with it you can connect many components together. If you may notice that many breadboards have numbers and letters marked on the various rows and columns. These don't serve any purpose other than helping guiding you when it comes to building your circuit. Circuits can get very complicated, and I'll show you some of the complicated TinkerCADs that I have. So all it takes is can be one misplaced leg of your component, and your entire circuit can malfunction, which is no fun. So if you know the row number of the connection you're trying to make, it just makes it much easier to plug in a wire to that point or to that coordinate rather than just eyeballing it. And this is more like a little fun fact. Many years ago when breadboards weren't invented, and because they were so big and bulky, people would actually grab their mom's breadboard, a few nails or thumbtacks, and that's when they started connecting wires into the board to give themselves that platform which they needed to build their circuits. So that's how they got the name breadboard, which I thought was cute.
Yeah, history of it.
Yeah, very innovative. So some of the major features of a breadboard are the terminal strips, the dip support, and the power rails, which I'm going to talk about. So the terminal rails, terminal strips, not rails. The tops of the metal rows have little clips that hide under the plastic holes. So these clips actually allow you to stick a wire or the leg of a component onto the exposed hose on the breadboard, which then holds it into place. And once inserted that component, it will electrically connect it to anything else placed in that row and in that row only. This is because the metal rows are conductive and allow current to flow from any point just within that strip. And you can kind of notice that there are 5 little clips on that strip. Like if you ever break down a breadboard, you're gonna see these metal clips. And this is typically on almost all breadboards, which means you can have only up to 5 components connected in one particular section of that breadboard. And you can also notice that each horizontal row is separated by the dip support, which is right here. And so that isolates the both sides of a given row from one another, so they're not electrically connected. So when it comes to the dip support, like I said before, it just isolates the 2 sides of a breadboard. The dip support serves a very important purpose. Many integrated circuits can use ICs or ICs chips, and they're manufactured specifically to fit onto breadboards. And in order to minimize the amount of space they take up on the breadboard, they come in what is known in a dual inline package, which is dip. And so these dip chips, or the IC chips, they have little legs that come out on both sides, and they fit perfectly over that dip. And since each leg on the IC chip is unique, we don't want both sides to be connected to each other. So that's where the separation in the middle of the breadboard comes in handy. Plus we can connect more components to each side of the IC chip without interfering with the functionality of each leg on the opposite side. Does anyone have any questions? I don't know if I'm going too fast. Or for anybody that doesn't have any experience with a breadboard, are we all good?
Yeah, I think you're going at a good pace.
Okay, awesome. If not, just let me know and I can slow down, or I can kind of reiterate some things. So when it comes to the power rails, aside from the horizontal rows, the breadboards usually they have what are called the power rails, and that they run vertically along the side marked with the minus or plus sign, or the negative and positive labels. And these columns or horizontal rows are typically used to provide power to your components by connecting your power source, which in this simulation we're going to use a power supply, but I'm also going to show you how we can use a battery as well. And when building a circuit, you tend to need power in lots of different places. So the power rails give you lots of easy access to power wherever you need it in your circuit. Usually they're labeled, like I've said before, with a positive or a negative, or red and blue or black stripe, which are usually the more universal colors. And those indicate like the positive and the negative. Usually, especially in our lab, we have negative as black and positive as red. So it is important to be aware of the power rails on the either side are not connected. So if you want the same power source on both sides, you need to connect both sides with the jumper wires. Usually when something's not working, the first thing they do is like check your ground, check your power, because sometimes those aren't connected to each other. And so also keep in mind that the markings are just as a reference. So, typically there is no rule to say you have to plug the power into the positive rail or the ground into the negative, but that's just more like of a universal and just, I guess, good practice so you're not confusing yourself by flipping things around. So now that you kind of know how a breadboard works, we're going to go on to our example. So the materials that we're going to need are a small breadboard, a power supply, a push button, a resistor, an LED, and wires, and all that's going to be on our TinkerCAD. Also on the PowerPoint, I did place a video on how to use TinkerCAD, so in case you need something to reference back to or you get lost, if you're too embarrassed to ask me, you can always go to this video and I kind of break it down how we're gonna do this example. So if everyone can move to TinkerCAD. So usually your home page kind of starts off here with 3D designs. You can ignore this. You're gonna go right here on your left hand side to circuits. And here on the top is where you're gonna click a new circuit. But as you can see, like when it comes to more complicated things, it's easy to know the different parts of your breadboard, and also color coding. I really love that. I know after a while there's only a certain amount of colors on the breadboard, but it's good to be organized because you can simply mess up. Let's see if this loads. This is actually one of my labs for digitals. Oh man.
Are you showing the screen? Because I can't see anything besides the PowerPoint.
Oh my god, let me see. Let me show you. Change windows. Okay. Oh, you know what? Don't tell me the side is down. Oh no. Okay, can you guys see it?
Yeah, I can see it. Well, now it's refreshing, but yeah.
Yeah, it's refreshing. Bruh. We'll just give it a few seconds. No. Okay, so this is actually one of my labs. I was for digitals. As you can see, it's super messy. And these right here, if you guys don't know, these are actually the IC chips. And there's so many. There's like and, or, NAND, NOR. So, but let's go to where we make our own. So you're gonna press here, create new circuit. And so this is how it should look like. Is everyone here?
Yeah, I'm there.
Yeah, awesome. Okay, usually here it always gives a different name all the time. So you can always click up here and you can always change the name. I'll just put LED, or yeah, I'll just put LED IEEE. You guys can name it whatever you like. So here on the right side is where you can have many, as you can see, many different components. If it so happens that something you want is not here or you don't want to scroll for it, you can simply search here. Like we can search power supply or just power. And you know, as soon as you type it, the products that relate to the words or the keywords that you're searching for usually pops out. So today we're going to be using a power supply, so you can just simply click it and drag it to your screen. You can pretty much drag it everywhere. And like in labs, sometimes they give different voltage and different currents, so that's where you can kind of play with up here. But just for this purpose, we'll just keep it right here at 5. So next we're going to click on the small breadboard. You can place it anywhere you like. Here, let me zoom in for you guys. Wait. Oh my gosh, too much zoom. Okay, so here we can already connect. As you can see here, like on the power supply, it kind of notifies you. Like here it says negative, so if this one's negative, obviously this one's positive. And as you can see here, the positive is red and the negative is black. So you can, to simply connect your power supply to your breadboard, you can just click on the negative, and you can either go directly, or if you want to make it pretty, or go all around, you can move however you like. And these little circles right here, I don't know if you can see, you can kind of move it around if you don't like the shape, or oh, sorry. And then here as well, where it says wire and colors, you can change the colors. So since we don't get confused, I'm just going to put black so we know that that's for ground. And we're going to do the same thing with our power. But I'm going to connect my power over here just so we can see things a little bit more clear. So now that we have our ground and power connected, we can get our LED. If the LEDs wasn't there, we can simply search for it. We can click on it, and you can place it anywhere on the board that you like. But I'll just place it right there. And here you can change the name of the LED if you like, or the color as well. I'm going to choose blue, you know, to represent IEEE. And as you can see right here, it will also label like the different pins, because for those of you that don't know, like for the LEDs, there is different pins. We have the cathode and the anode. So one of them is for positive and the other one's for negative. And sometimes you can see here, like one is bent and one is straight. So usually the shorter one is the cathode, which is the negative, and then you have the anode, which is the longer one, which is right here, as the positive LED. So since this one's positive, we're going to connect it to our positive power rail. We're going to change it to red, but you can change it to any other color that you like, but I'm just going to choose red so we don't get confused. Is everyone okay at this point? Just want to make sure no one is lost.
Yeah, so far so good.
Yeah,
Good.
awesome possum. Okay, so obviously to power our LED, we're gonna need a resistor. So since we don't see it here, I mean it's right here once I click it, but if you couldn't see it, you can just simply type it out. And we're gonna place it right parallel to the negative part of the LED, as you can see. And the same
series.
I'm sorry, what?
Because you said parallel.
Oh, sorry, yeah, like horizontal or vertical, however you guys see it. Ooh. And the same thing as well, if you click, oh my lordy lord. If you click over the resistor, oh my gosh. You can change the name, you can change the units, you can change how much power you give it to. So the resistor, for those of you that don't know, a resistor just restricts the flow of electricity in a circuit. It just reduces the voltage and the current. So just to make this a little bit more fun, we're gonna add a push button. And the push button is just a switch that closes a circuit while it's being pressed. So the same thing as well when it comes to a push button, it is labeled here. It says terminal 2B, terminal 1B, terminal 1A, and terminal 2A. So a push button structure, as you can see, it has 4 legs, you know, 2 on one side and 2 on the other. And so they can operate 2 lines of the circuit by a single push button. And so the 2 legs on both of the sides are internally connected. So the working concept of a push button is so when the button is pressed, it conducts current through, or it makes a circuit. And so when the button is released, it breaks the circuit. So all we're gonna have to do next is make sure we connect it to ground. So in order to, whoa, this thing has a mind of its own.
You can press the square to center it.
Yeah.
On the top left.
Okay, so just like, you know, in any traditional lab, we're gonna have to turn on our power supply. So from here, once you have all your components, you're gonna press start simulation. So as you can see that your power supply is on, and it says right here it's on. And when you stop it, you can see where it says off right here. So we're gonna turn it on. And then once you press on your push button, it's gonna turn on your LED. Was everyone working? Did everyone work? Yes, awesome.
Working for me.
Okay, cool. So when it comes, so let's say I did something wrong and I wanted to change something. So you can, you know, so it's good practice by force. You're gonna have to stop your simulation so you don't get electrocuted by your power supply turned on. And that's when you can change something if you like, or, you know, you can move things around. And also sometimes when you use IC chips and you kind of connect it wrong, like it'll give you an error on saying why something is wrong. So that's what I kind of like about TinkerCAD as well, because, you know, traditionally when you're there, like no one's gonna tell you what is wrong with your circuit. But on TinkerCAD, like if you were to use too many components, or one component breaks, or for whatever reason, like it kind of notifies you. So here now we're gonna switch from a power supply. We're just gonna delete that, and we're gonna oh my god, we're gonna add a battery. Ooh, let me minimize this. And also you can flip things around. Oh wait, no, right here you're gonna use this little where it says rotate, and you can just rotate things around if you like. And the same thing as well, like everything, it is labeled. So positive, we're going to connect it to our positive power rail. And then for good practice, we're going to color it red so we don't get confused. And the negative, if you want to crisscross to here, you can, but if not, you can go all around if you like. It's up to you, however you want to. You can just go straight through, it doesn't really matter. For good practice as well, it's going to be black. So then once you press start simulation, you just click on your push button and it turns blue. And then also, depending on the brightness, you can also change the units. So let's do what, like ohms? I don't know. We can do whatever, 100. See, oh, I forgot to press stop. You see how it has like that little exclamation mark? And then also, if you want to add a note, you can as well. So you can put here, write a note. But hi guys. So just in case, you know, for whatever reason, when your circuit gets too complicated and you want to add a note or make sure you're still missing a wire here or wire there, that's where you can kind of add the note. So that's pretty much how TinkerCAD, I know this is like a simple simulation, but you guys can kind of play around with it. We can change, let's see. Whoop, misspelled resistor. Dude, this thing is so sensitive. I'm trying to get... So here you can change the units. You can put 100 and then start simulation. And you can see that it got brighter. And look, it says here, current through the LED is 65, what is that, milliamps, while recommended maximum is 20. So it will tell you like if something is wrong or there's an error. And you see the usable lifetime of the LED may be reduced. So that's why I really find it useful, because for whatever reason there's an error message or something is wrong, like it'll let you know.
I'm wondering, how did you get that error message to show up?
It just, like, you can ask for an error message, obviously, like it's just gonna pop up. Like, did it pop up for you or no?
No, not really.
Oh, okay. You see, like here, like you can see that it broke, and you can go over it. That's all you have to do. Like if you get like a little error message or a little, like here that has like a fire pop. Let me zoom in. You just scroll over the message and I'll let you know what happened. So you just scroll over and it says there, current through the LED is 255 milliamps, while absolute maximum is 20 milliamps.
Oh, okay, I see it now.
Yeah. So then you have to press stop, and then you change. We can always change the units. And the same thing as well, it'll give you another error message. So if you guys want to play around, you always can. But from here, we're going to go back to the PowerPoint because I have a little Kahoot from you guys. Just as in a little incentive, the winner of the Kahoot gets their name in our IEEE raffle. So they get one entry. So let's go over to Kahoot.
It's on.
Oh, let's see. Let me change windows. Oh. Can you guys see the screen?
Yeah.
For the Kahoot?
Yeah.
Okay,
Yep.
awesome. Awesome possum.
Cool crocodile.
What? I've never heard of that before. I'm gonna use it. Cool crocodile.
What the hell?
Actually, no.
I just made it up with the
Oh. I was like, oh, I like it. I like awesome possum. Orale.
Is this limited to just members, or can some officers join in?
Yeah, if you guys want. I think since I only have like the basic, I think it only allows like 10 players. But I don't know how many are we. But yeah, everyone can join. Is anyone using TinkerCAD for any of their classes? Or what are you guys using to simulate labs for those that do have labs?
In general, just PSpice.
Oh, PSpice.
They gave us an actual
right now.
Oh, I didn't hear you. Who was that? Was that you, Marky?
Yeah, I'm using a Logicin, like very, very basic.
Oh, okay. Oh, awesome. We'll wait. How many? There's 6. We'll wait a couple of more minutes to get everybody. 1, 2, 3, 4, 5, 6. And then, like I've mentioned before, the people that join in today, you guys get a point, so you can later cash in those points for any prizes. The PowerPoint will be uploaded on our Discord for reference, or for anybody that didn't tune in. And then the recording of this workshop will be posted on our YouTube channel. Is this everybody? I want to press start when I'm missing somebody. I'll give it 1 more minute and then I'll start just in case. So there's 6 questions and each question is 30 seconds long, so use your time wisely. But I promise it's not hard.
I didn't study, so please.
Oh no. And during the PowerPoint, I try to emphasize on some things that are going to be on the quiz.
Oh shoot.
So I don't know if y'all
look at the recording.
I know. Let me go back. But it'll be fine. It'll be fine. If you paid attention. So I wasn't yelling at you guys. I was just trying to emphasize. Okay, it's already been a minute, so we're gonna start. Is everyone ready? Before I press start and you guys are not. Okay, we're gonna start in 5, 4, 3, 2, 1. Boom. So the first question is a true or false. TinkerCAD first became available in 2008. Is it true or is it false? So yeah, the answer was false. It actually first became available in 2011. Ooh, go Mario. So the next question. Written in WebGL, it is a blank application programming interface.
Oh man, I want a coffee now.
Oh, yeah, the answer was JavaScript. Oh. Ooh. Let's get it.
Getting competitive.
I know.
Got 'em all. Ooh.
Yeah, the faster also you click your answer, the more points you get. So, you know, just because you get the answer right, you gotta be fast too, but efficient. So let's move on to the next question.
Full sonic speed.
What is a major feature of a breadboard?
What are those answers? Powerpuff Girls and Power Rangers.
Yeah, the answer was Power Rails. Hey, you'd be surprised. Ooh, Miguel's on fire. Love it. So the next one, true or false? The terminal strips are vertical rows of metal strips that are conductive and allow current to flow. And the answer was true. Oh, Mario, you're in first. Let's click next. What is the purpose of the dip support?
Squidward left. That's how funny that was.
Oh, yeah, it was to isolate the two sides of the breadboard.
What the hell?
Ooh, Marky's on fire. So last question, guys. So be prepared. Stretch your fingers. And let's get it.
Isn't it cross?
Power rows are horizontal rows that allow easy access to power. Oh. Yes, the answer was true. So let's see the winner.
I thought they were vertical.
No, the horizontal. Vertical are terminal strips.
Ah, clever.
Mm-hmm.
Are you sure?
Yes. We can go back to the PowerPoint. I hope. If not, I owe you guys. Boom, baby. Horizontal rows that allow easy access to... Oh, can you guys see?
Yeah, we can't. We're still at the Kahoot.
Oh,
We're like, what are you talking about?
sorry. Boom, baby. Horizontal rows that allow easy access to power. So let's go back to the Kahoots to see who is the winner for an entry in our raffle.
Check your DMs, Myra.
Okay, going. Oh wait, but I'm recording the whole screen. On, oh my gosh. Oh, Marky! Yay! Good job, good job.
Thank you. Oh, I got so when you called me out, I got so nervous on the last question.
Oh no!
I was like, oh, this is it. Like I messed up.
No.
Nah, it's all good. All good.
Yeah.
All fun.
Yes. Let me just take a picture of this. Awesome.
Kahoot.
Kahoot. I love Kahoot.
I don't. I hate that music.
Oh.
Come on, it's a banger.
I know.
Nah.
And let me go back to the PowerPoint. Okay, let me exit the Kahoot. Leave page. Okay, awesome. So I just want to say thank you for everybody who tuned in on our workshop Monday on our Breadboard 101 and TinkerCAD Workshop. If you guys have any ideas on workshops that you guys want to learn, if there's anything you're interested in, you can always let us know. Or if you're having a trouble for a class, we can always do a tutoring session or transfer it into a workshop. Or if you guys have also projects in mind as well, please let us know, and just remember that we're here for you guys. We want to provide for you guys, you know, the best services and the services you deserve. So if you guys have anything in mind or need funding for your project, yada yada, please let us know. We're here for you. Other than that, thank you so much everybody for coming. Congratulations to Marky, our awesome winner. And yeah, so I'll be posting the slides on Discord, and then the recording of this will be pasted on our YouTube shortly, and I'll be providing the links for that. So thank you everybody for coming.
Thank you, Myra. It's a great presentation.
Yes, thank you.
Thank you. Good one. Thank you.
Thank you, you guys too.
Thank you.